Okay, good day. This is Math 140, College Algebra. I'm Professor McCulley. This is Lesson 5.1, Functions, Domain, and Range. Let's get to it. Today we're going to determine if a relation between two variables is a function. We're going to use function notation and evaluate functions, and we're going to find the domain of a function. So let's get some definitions here. The definition of a function, f from a set A to a set B is a relation that assigns each element x in set A to exactly one element in set B. And the set A is the domain of the function, and set B contains the range. So a couple things here. The big one is not every element in set B must be used for the range. So you can have elements in set B that are not necessarily in the range, and I'll show an example of that here fairly shortly. Characteristics of a function from set A to set B. Each element in A must be matched with an element in B. Some elements in B may not be matched with an element in A. I just said that. Two or more elements in A may be matched with the same element in B. An element in A cannot be matched with two different elements in set B. And if you remember from your algebra days, this last one here is your vertical line test. And I'll show you an example of that here in a second, but hopefully you remember that. So let's talk some examples here. Let's pull up a graph. I don't want that. Let's just pull up a general Cartesian graph. That works for me. And if I were to get my line tool out here and I would make a line, a linear equation is always going to be a function. And here is going to be my set A, the real numbers, along the x-axis, and here is my set B along the y-axis. And for every single point that I pick in set A, there is exactly one point in set B. And so what I can do is I can create a vertical line here, and any place that I take that vertical line and I pass it across this function, it only crosses that function, or the function only crosses the vertical line one time. And that's what's important about having a function, that that's the only thing that happens. Now, if I were to make another graph here, and let's move this over just a little bit and draw a parabola in here. A parabola is also a an example of a function because it does in fact pass, oops, I want that, there you go, pass the vertical line test. But there are values for y that have two x's. So at 2 we have approximately -4, and at 2 we also have approximately 3.5. All right, for the x values. So that's allowed. And this also is an instance where we say that our set B, the y-axis, has values that are not used. So the range of this particular function is going to be something that's y is a little bit bigger than -3.5-ish. I guess we'll figure that out eventually. All right. Now something that you can have for a function, and let's grab one more graph here and pull it down so we can see this, is if I drew a graph in that looked like this. All right. And if I grab this vertical line here and brought it down there, here we can clearly see that this vertical line does not, this vertical line has two y values for a given x value. If I move it over to 2 here, we can clearly see that there's an x, this x value -2 has two y values that it corresponds to. So this one right here is not a function. All right. Function notation, f of x denotes the name of the function and the variable for which it defines. So if we talk about this expression right here, and we'll say h of x is equal to x squared plus x plus 2, and we'll say that the function h is defined by the variable x, so our h is defined in terms of only x. X is the independent variable, y is the dependent variable, and in this case, y is our h of x value, whatever that might be, when we plug in some points. The domain of a function, the domain of the is a set of all real numbers for which the function is defined. And so we have some three big questions to find the domain. We'll start with all real numbers. Most of the functions that you will, or most of the equations that you will encounter, the domain of those functions are going to be all real numbers. And so we start with all real numbers, and then we remove values based on these three rules. We're going to remove all real numbers that cause a division by 0. So if you see a division bar and a variable in the denominator, you might need to use this to remove some values based on this rule. You have to remove all real numbers that will cause the even root of a negative number or a logarithm of a negative number. Those things are not in the domain of a function. And then you must remove any real number that does not make sense in the context of a problem. So if you're dealing with a word problem where the independent variable is number of TVs made, you cannot make a negative TV, so you might have to limit the domain in that particular instance. Let's talk about some examples for finding domain. We're going to do some by hand, and we're also going to use the graphing calculator to get us that was at least part of the way there. And so if you're given just a set of values, it says find the domain of this function f, which is defined as a set of 4 ordered pairs. The domain for this thing is going to be the set of values 1, -2, 0, and 4. It's going to be the x values of each of those sets. If we talk about a linear equation, g of x is equal to x plus 2, and let's go talk about the rules here because this is an easy one. We start with all real numbers, and we remove any number that will cause a division by 0. Well, if I look at this function here, I have no x's in the denominator of a fraction, and so I can't get a division by 0 that way. Remove all real numbers that cause the even root of a negative number or the logarithm of a negative number. Well, this particular function doesn't have a root symbol in it and doesn't have a logarithm symbol in it. So I can't throw out any numbers along the x-axis based on that. And in fact, any linear function has a domain of all real numbers. And if they asked you to put it into let's say they wanted, so this is just me writing it out, interval notation would be from -infinity to +infinity, and that's going to be inclusive. And if you would like me to go over interval notation in more detail, I can do that during our class time. I'm going to do these last couple using a graphing calculator to at least get us started. The volume, it says this one is the volume of a cube. So this has something specific, and then it gives us an equation. And so the first thing I want to do, I'm going to go to my y equals. I'm going to put in x cubed, so x raised to the 3rd power, and I'm going to hit graph. Now, if this particular function, it looks to me like it's going to continue on to go to the left and to the right, and if it was just this part, v equaling x to the 3rd, we would probably say all real numbers. And again, if I talk about the rules, there's no divisions by 0, there's no even roots, there's no logarithms, so all real numbers. But because this is the volume of a cube, and you cannot have a negative volume, so I want to look at this graph here. This is the length of the cube along the x-axis, and along the y-axis we have the volume of the cube. And so when I talk about this particular instance, because we're talking about volume, we can't have negative volume. So our domain starts where it begins to have positive or 0 volume. You can have no cube there, that makes sense. And so this particular instance, my volume in the domain is going to be all the values of x where, let's do this right, all the values, all reals, where x is greater than or equal to 0 in that particular instance. Okay, so let's talk about this next one. H of x is equal to the square root of x minus 2. Let's take a look at what that graph looks like. Clear here. And so second square root x minus 2, and we hit graph. And we look at this particular instance here, and it looks like I got a little bit of a gap right there. And so, um, but what I do notice is that -10, -6, -2, -1, 0, 1, and possibly 2, there's no graph there. It just starts right there. There's nothing over here that's been graphed. And so I can use my domain, my graphing calculator to get me an idea of what the domain's going to look like. And so it looks to me like it might start just a little bit after 2 based on what the graph looks like. But we still have to follow the rules. We start with all real numbers. We remove any value of any real number that will cause a division by 0. Well, if I look at this, I got no divide symbol, but I do have this third one where it says it cause the even root of a negative number. All right. And so when I look at this particular thing, I do have that even root. It's a square root. And so what would give me a negative number? Well, if I plugged in 0, 0 minus 2 would give me the square root of -2. So if I look back here, the reason 0 doesn't have a graph is because it's going to give me an imaginary value. All right. So what is the smallest number that I can make for x that will cause this expression to be greater than, or at least 0, because I could take the square root of 0. Well, if I think about it, 2 will make this 0. 2 minus 2 is 0, so square root of 0 is 0. And so when I look at this graph, it actually starts at 2 and then moves up. So we have, like I said, the graphing calculator is a good tool to get us started, but we do have to make sure we check it. So our domain for this thing is going to be all reals where x is greater than or equal to 2. Now for this last one here, we're going to put it into our graphing calculator again just to get a check. So I'm going to clear this out. I'm going to go, I don't want to go second, I want to go alpha y equals to bring up my fraction. And so if I check it one more time, it was 1 over x squared minus 4. So I'm going to put my 1 there. I'm going to go x, and hit the square button, minus 4. And we're going to graph this thing. And I get these weird shapes here at -2 and +2. And these things we're going to talk about later. They're called vertical asymptotes. They're imaginary boundary lines where the graph has a discontinuity, a place where it's undefined. And so again, we're going to follow the rules. We'll start with all real numbers, and we're going to remove values that will cause the division by 0. Well, we've got variables in the denominator here. We've got a variable in the denominator, so we have a potential to have divisions by 0. And if I look at the graph, it looks to me like at -2 and +2, I've got something going on there. And so when I look at this particular case, if I plug in -2, -2 times -2 is +4. 4 minus 4 is 0. 1 divided by 0 is undefined. The same thing happens at 2. 2 squared is also 4, and I'll get a 0 in the denominator. So the domain of this thing is going to be all reals where x is not equal to +2 or -2. And that's going to be my domain. All right, moving on. The difference quotient. The difference quotient relates to the slope from calculus and slope equation in calculus, and you'll see this if you do get to calculus. But essentially what it does is this. If I pick 2 points, and I could call this point x1, y1, and this point right here x2, y2. All right. The slope between those is the difference in these two x's over or underneath 2y. So let me start over. If I go y2 minus y1, and then I put that over x2 minus x1, I will get the slope of this line right here. But if you think about it, this distance right here, if I call this distance x2 minus x1, we could call that a numerical value h. and that's where I get this. And if this is my function value, and I call this just x, then this point right here would be f of x. And if I talk about this place here, h, this point right here, if this is x, then this point here would be x plus this distance here, which we call that h. So this is x plus h, making this point right here f of x plus h. And so my slope equation, m, y2 minus y1 over x2 minus x1 becomes this y, f of x plus h, minus this y, f of x, minus the expression that we came up for x2 minus x1, which is just h. That's how we get the difference quotient. All right, it says find the difference quotient for the function. So we have this function right here, and we want to find the difference quotient of that, and it's f of x plus h minus f of x all over h. And so f of x plus h, basically what that tells us is that wherever I see an x in this expression, I'm going to put x plus h. So the x squared becomes x plus h and squared, and then the x becomes x plus h. And from that, we're going to subtract f of x, which is just x squared plus x. And that's going to be all over h. And so this is the difference quotient. But rarely are you going to get a problem where they don't say and simplify. So we're going to simplify this. Now, remember, you have to multiply this out. X plus h quantity squared is x plus h times x plus h. And so you actually have to multiply this out. Please don't be that person that puts x squared plus h squared. You're going to be wrong all the time. And so we multiply this out, and I'm going to do it quickly, and if you need me to go over it, I'll do it in class time. But it's x squared plus 2xh plus h squared. That's this expression. Then we have x plus h, and then to get rid of these parentheses, we have to distribute the negative to the x squared and then to the x, and that's going to be all over h. And now we're going to cancel. And so I've got an x squared there that cancels with that x squared. I've got an x to cancel with that. And then I'm going to simplify. And so I get, let's see here, 2xh plus h squared plus h all over h. Notice each term has a factor of h. And so I can divide it out. So 2xh divided by h is 2x. H squared divided by h is just h. H divided by h is 1, and then this bottom h divided by h is also 1, but we would never put everything over 1 as our final answer. So we're just going to leave it like this, and that is my simplified answer. And we'll be done with that. Okay, what is the domain of this function? Well, the domain of this function is, if we look at it, x squared plus x. We start with all real numbers, and there are no divisions by a variable. There's no even roots. There's no logarithms. So the domain of this thing is all real numbers. All right. Find the domain and range of this particular function. All right, so let's talk about the range. The range are the values that come out of this function. So let's take a look at the graph here. Let's clear this out here. And it was square root, oops, I need to get rid of that. Second, square root was x, and let me check to make sure, minus 4 plus 2 on the outside, so minus 4, and then plus 2 on the outside, and we hit graph. And again, we have a square root, and so clearly, there are values of x that don't have graphs, and that is because we have this even root symbol in there. And so we got to figure out what will cause that square root of a negative number. And so anything less than 4 will cause a negative number. So my domain are going to be all reals where x is greater than or equal to 4. And then my range, well, my range is the y values that are graphed. All right. So if I look at this graph here, my y values, there's some y values that aren't graphed, and it looks like it starts at 2. So it starts like 2 and goes up. So my guess from my graphic calculator is to say that my range of my y value is greater than or equal to 2. And so can we verify that looking at this thing? Well, when x is equal to 4, that's the smallest x value I can plug in. I get 4 minus 4 is 0. The square root of 0 is 0 plus 2. And since I can't make this expression negative, the smallest value that I can get out is 2. So my range is all reals where y is greater than or equal to 2. Well, that's all I got for today, folks. So today's Marvel fun fact of the day is Brie Larson filmed all of her scenes for Avengers Endgame before she filmed any for Captain Marvel, which actually came out as a movie, was released before Endgame. Is it time travel? I don't know. You tell me. That's all I got for today, folks. Have a great day. Bye.